The second-generation Blade battery, a true game-changer. Since its debut in 2020, BYD's Blade battery has stood out in the world of electric vehicle batteries. Unlike conventional battery types that use nickel, cobalt, and manganese, which are costly and prone to overheating, BYD's battery utilizes lithium iron phosphate chemistry, making it safer, more affordable, and longer-lasting. But now, the company has taken its technology to the next level. The next-generation Blade battery is significantly improved. Its energy density has increased from 150 watt-hours per kilogram to 190 watt-hours per kilogram, representing a 27% boost in efficiency. This means electric vehicles can travel much farther on a single charge without increasing the size or weight of the battery pack. Charging speeds have also been upgraded. The new battery is capable of charging from 30% to 80% in just 30 minutes when connected to a 110 kilowatt direct current fast charger. This addresses one of the biggest concerns among electric vehicle owners, charging time, by making recharging as convenient as refueling a gas-powered vehicle. Another key advantage is cost efficiency. BYD has streamlined its battery production, making the second-generation Blade battery cheaper to manufacture than the first version. Lower production costs mean lower prices for electric vehicles, increasing affordability and encouraging more widespread adoption. Beyond efficiency and cost, the Blade battery is also one of the safest options on the market. Traditional batteries that contain cobalt and nickel can catch fire under extreme conditions, but the Blade battery has passed rigorous safety tests without overheating or combusting. Even under stress tests like nail penetration and exposure to high temperatures, it remains stable, proving its reliability for long-term use. With faster charging, longer range, lower costs, and unmatched safety, the second-generation Blade battery is poised to set a new standard in electric vehicle technology. But this advancement raises an important question: how will industry leaders respond to BYD's innovation? How this changes the future of the electric vehicle industry? For years, companies like Tesla, General Motors, and Volkswagen have relied on traditional lithium-ion battery chemistries that contain expensive metals like cobalt and nickel. While these batteries provide high energy density, they come with serious drawbacks. They are expensive to produce, have supply chain issues, and are prone to overheating. BYD's lithium iron phosphate battery eliminates these problems entirely. Since it does not use cobalt or nickel, it is significantly cheaper to produce while maintaining exceptional durability. This cost advantage allows BYD to sell its electric vehicles at lower prices without sacrificing quality or performance. Tesla, recognizing the benefits of lithium iron phosphate chemistry, has already started using similar battery technology in some of its entry-level models. However, BYD has been developing this technology for years and is now miles ahead of its competition. With the second-generation Blade battery, BYD is not just competing, it is leading. The ability to charge quickly, last longer, and remain affordable positions BYD as a major threat to established electric vehicle manufacturers. If competitors cannot develop a battery that matches BYD's advancements, they may struggle to keep up as the industry moves forward. Additionally, as more companies shift towards sustainable transportation, the demand for lithium iron phosphate batteries is expected to rise. BYD has already secured its place as a dominant force in battery production, ensuring that it will continue to grow as demand increases. The second-generation Blade battery is not just an innovation, it is a turning point for the entire industry. But how exactly did BYD manage to create a battery that is so much better than anything else on the market? The answer lies in its relentless commitment to research and development. How BYD achieved this breakthrough? BYD has been working on its second-generation Blade battery since the day the first version was launched. The company's goal was clear: make the battery safer, more powerful, and more affordable. The result is a battery that outperforms its predecessor in every possible way. The biggest improvement comes from enhanced energy density. Traditional lithium iron phosphate batteries were historically less energy-dense than their nickel and cobalt counterparts, meaning they required larger battery packs to achieve the same driving range. However, BYD has optimized its battery chemistry, allowing its new battery to store more energy without increasing its size or weight. A major factor behind this improvement is better material composition. The next-generation Blade battery uses refined raw materials that improve thermal stability, meaning it generates less heat during operation, reducing energy waste and increasing efficiency. Another key breakthrough comes from manufacturing advancements. BYD has developed a more streamlined production process that significantly reduces costs. By optimizing its supply chain and improving the design of battery components, BYD has made mass production more efficient than ever. Battery safety remains a top priority. The second-generation Blade battery continues to excel in rigorous safety testing, including exposure to extreme heat, crushing, puncturing, and overcharging. While traditional batteries can become unstable under these conditions, BYD's battery maintains its integrity without catching fire or losing capacity. With these innovations, BYD has effectively solved the biggest problems facing electric vehicle batteries today: high cost, limited range, long charging times, and safety risks. The second-generation Blade battery sets a new benchmark that competitors will struggle to match. As the world shifts toward electric vehicles as the dominant mode of transportation, BYD's advancements position it as a leader in the battery market. But there is an even bigger question. Could this be the technology that finally makes electric vehicles more affordable than gas-powered cars? Faster charging, longer range. For years, electric vehicle manufacturers have struggled with one major issue: charging speed. While advancements in battery technology have improved range, most electric vehicles still require long charging times, making them less convenient for drivers compared to gas-powered cars. BYD's next-generation Blade battery could change that forever. One of the biggest improvements in the new Blade battery is its charging efficiency. With an optimized battery structure and refined lithium iron phosphate chemistry, BYD's engineers have significantly reduced internal resistance, allowing the battery to charge faster without generating excessive heat. As a result, electric vehicle owners will be able to charge their vehicles from 30% to 80% in just 30 minutes using a 110 kilowatt direct current charger. This is a huge leap forward for electric vehicles. Imagine stopping at a charging station for a quick coffee break and returning to a vehicle that is already charged and ready to go. For many drivers, this is the final barrier that has kept them from switching to electric vehicles entirely. Faster charging means greater convenience, reduced wait times, and an overall better driving experience. In addition to faster charging, the next-generation Blade battery increases overall driving range. With an energy density of 190 watt-hours per kilogram, up from 150 watt-hours per kilogram in the first generation, BYD has effectively